welcome to Rusa. Every person at some stage of their lives have been somewhat curious about the origins of the universe. Why it is here? Why does it exist? Will it always exist? Has it always existed? Thanks to this question, we have come up with some mind-blowing theories about the origins of the universe. Theories like the Big Bang and cosmic inflation. However, there is a new hypothesis that the universe may have been born out of the collapse of a black hole, rather than spontaneous expansion. According to the Big Bang theory, the Big Bang was a period of rapid inflation when the universe was infinitely dense in a singular moment in time. It happened everywhere all at once. The universe was at a very small fraction of a second of the size of a full stop on a printed piece of paper, then expanded extremely rapidly, and still is today at an increasing rate, expanding faster than the speed of light. We do see this expansion, described as the mysterious dark energy. This dark energy makes up 68% of the energy observed in the universe. Here is an audio simulation of the sound waves resonating through the universe in the first 760,000 years after the Big Bang, based on data from the Planck 2013 and the WMAP created by physicist John Kremer. This audio file sounds a little bit like an explosion. If you listen closely at the first second of this sound file, to me, I think it does sound a little bit like an explosion, although it's probably not technically classed as an explosion. Amazing, right? This sound is of a frequency that's apparently resonating throughout the universe as it's expanding. What this actually means, I'll leave up to you to research. Speaking of expansion and the size of the universe, we cannot be certain that the universe is finite or infinite, but most arguments suggest that it's finite. After all, we can never really prove that the universe is finite or infinite, because we've never observed a wall or a barrier in the universe. Many people misunderstand the concept for how the universe is expanding. It isn't thought to expand as if there is a giant arbitrary wall surrounding the universe and everything inside it is classed as part of the universe and outside it is classed as not the universe, that there is an edge at all and that you will fly into it inevitably if you keep going in the same direction. The universe unlikely has a barrier in that way. It's thought you could keep going in the same direction forever, but that does not mean the universe is infinite. Because it's expanding, you cannot make infinity bigger. You cannot add 47 to infinity and get infinity and 47. Infinity is infinity. It's not finite.
However, the fabric of these space-time fields is what is expanding throughout space. Think of this balloon. I've drawn a line and a circle on it. The surface area on this balloon with this line here is much smaller than what it would be if I blow it up. The surface area of this dot is about the size of a pea at the moment. However, the surface area is roughly the same size as a 50-cent coin now. This line, along its length, has been affected more by the expansion rather than its width or its thickness. This is a good analogy for how the universe is expanding. It's not that there's a wall outside of us that's expanding away from us. It's that the smaller sizes in the field are affected less. Individual subatomic particles are affected much less than larger distances. It's the dark energy that is affected. However, that's not how the universe works.
Take something as mundane and boring as a rubber band, for example. A generic race course, or a closed loop, or better yet, the surface of a planet. These things are finite. Yet there's never an end to how many times you could loop them. You could walk around the surface of a planet forever. You could drive on a race course as many times as you want to. And you'll never hit a limit. It's not like you're ever going to hit a wall and run into it and never going to be able to go any further. The universe does not have a cap for that. I think a common source of confusion arises from the idea that the universe is very empty, almost void of matter. Therefore, nothing exists there. But this is not true. There is always something there. This is in the form of fields and space-time. Quantum field theory says that everywhere throughout space there are quantum fields carrying energy in the packets or waves, like ripples in a lake or the ocean. But try visualizing this in 3 dimensions. These fluctuations in quantum fields give rise to the existence of all particles around us. It's hard enough for one to wrap their head around the fact that the whole universe is like a quantum field, like the surface of a lake, but in 3 dimensions. It's even harder to try and visualize why that ripple represents a single physical particle throughout the universe. One single electron in space, for example, is just one single ripple in the electron field. Along with all other electrons, they are all inherent of the same electron field, the electromagnetic quantum field. I find it a good analogy for how most ideas represent the universe's expansion. More space is being created, and it may also be the case that energy is being created too by this process, because quantum fields can never be in a totally relaxed state throughout space, and if more space is being created, then more energy is being created.
Our current observations of the universe support the Big Bang Theory, but like all theories, they break down. For example, with the Big Bang Theory, what happened before this time? We don't really know. A new theory described in the journal Physical Review D describes how the universe's dense collection of matter collapsed into a single point, rather than tracing back to where it all began. It's like what happens when matter is collapsed into a point. Our best theories say that when matter collapses to a point, such as the formation of a black hole, a singularity is formed. But we don't really understand this singularity, since information can never really travel outside of the black hole. Everything that goes into a black hole, as you know, never leaves the black hole, never leaves the singularity. So, what does this other theory suggest then?
This new approach proposes that gravitational collapse does not necessarily have to end in a singularity. This new theory shows that it's possible that a collapse can cause matter pulled in to become extremely dense, that it can rebound back into a new expanding phase. Could this be what happened at the beginning of the universe? Could there have existed a universe before this one? Scientists hope advancements in this theory will shed some light on mysteries like the origin of black holes, the nature of dark matter, and factors influencing the evolution of galaxies. It explains the early state universe without implying that there are mysterious forces at play. It predicts that fields throughout the universe are not uniform or flat, that there is shape to it, a curvature, like the surface of our planet. In science, it is important to hold some degree of skepticism or detachment when it comes to new theories, as they are theories, as the name suggests, and not proof of something to be true or set in stone. These are formulated on the basis of known principles and from ideas, but they are ultimately not the answer to something it attempts to explain.
Don't worry, our Earth has a lot of mass, but it's nowhere near enough mass to actually collapse into a black hole. Nowhere near enough mass or density. But its gravitational pull is enough to hurt when you jump off a place high enough. So, yeah.
Anyway, you've reached the end of my video / documentary thingy. Please reach out to me if there are any corrections that need to be made. After all, there are potential mistakes for misinformation and all that, etc. I can make mistakes, so do reach out to me if there are any corrections. Constructive criticism is accepted here on my channel. Anyway, guys, thank you for watching and welcome to Rusai.